Madam, can you give me the host access? Okay, just let me know in chat box whether you're able to hear me and the screen is visible. Just type chat box AB so that we can start the session. Okay, fine. Okay, we are discussing about this risk controls, risk avoidance, loss prevention, reduction, information management, and also risk transfer. These are other control measures. Then in the risk financing, like risk retention and also risk transfer, like insurance. Retention means how you are managing it. Transfer means, for example, you are paying employees health insurance. So here the risk of financial risk will go to the insurance company. You are transferring your risk. Program administration, day-to-day short-term plannings and also long-term plannings. By this, we can put the risk control measures. If you see the management activities, what will happen? So the basic steps of risk management are again identification of risk, analysis of the risk, then select and evaluate the remedies. So remedies in the sense corrective or preventive actions. So here you are select and evaluate. Once you select, and also you have to evaluate the remedy, whether it is a correct remedy or not. Then implement necessary safeguards, then audit and review if necessary. So once you have done this, your risk management activity will complete. If you see the risk reduction activity, what we do is the altering and modification of the hazard. So how you are going to reduce the risk, and altering modification of environment in which the hazard is existence, and intervening in the process whereby hazard and also the environment interact, example firewall within the structure, or to separate the fire prone areas and other areas, shock absorption, or to stop the transfer of vibrations, etc., etc. Here about the actions which you are taking to reduce the severity of the hazard. Now we'll see what are the some of the roles of the risk managers. Is nothing but safety officer. So assisting the organization in identifying the risk, implementing risk control programs, reviewing contracts and documents, example, safety audit, emergency planning, safety reports, etc., including insurance and also risk management purposes, providing education, training on safety matters, implementing statutory provisions, and arranging non-insurance financial schemes like self-insurance or captive insurances, claims and also litigation measurements, designing and coordinating employee benefit programs. These are the various duties the risk managers will have. Now we'll see one of the other technique for the hazard identification analysis, a preliminary hazard analysis. So this is an initial study to determine the hazard causes, effects, and controls, the fact of the proposed product or process or operations are known to determine the hazards. For example, for the product using electric power, the hazards to the pre-assumed or electric shock. For example, if you are selling any product, you are selling any mobile or any other electronic gadget which is works on electric power. So the primary pre-assumed hazards are shock, burns, fire, sparking, and also hot surfaces and inadvertent starts of the equipment, failure of the equipment to operate at a critical time to cause an accident, radiation effects, electrical explosions, etc. And similarly, adverse effect of the foreseeable causes will be like chemical exposures, reactions, acceleration issues, mechanical effects, and also pressure. These are the various kinds of hazards which will be there with your product. If you see, the pH is in the fast and also the cost effective and not complicated like the other methods hazard assessment. It should adapt to the first step in its basis will be assume the type of accident or hazard possible. So here we are thinking about what kind of accident will happen, either fire accident or explosion or toxic or any other thing. Find out which plant, component, system or machine can cause this accident. So here we are doing a reverse way. So we are assuming that what kind of accidents can happen. So with that accident, what are the causes or the contributory causes or the equipments or materials which will leads to these accidents. Then we'll find out the event or resulting initiating the hazard or accident. So that what will happen here, we'll have release of explosive or toxic runaway reactions or leaking or running without a guard. These are the causes for the incident or accident. If you see here, this will naturally suggest by the corresponding safety devices, safety valve or rupture disc or alarms. These are the various controls we can implement in. Then if you see the component systems that can be further examined by analyzing for the detailed failure and also how we can remove them. If you see in preliminary hazard identification, it requires a different stages of a project as under R&D. In R&D, what we do analyze the chemicals and reactions and impurities. In pre-design, we'll do hazard indices and hazard studies. In the design, we'll see a process design checks and also hazard failure mode effect analysis. Then in commissioning stage, we can do this in the by safety audits or mechanical compositioning test and also NDT and emergency planning. In operation side, we can do a condition and also the correction monitoring. These are the various areas we can use this PHI, preliminary hazard analysis. In PHI, it is generally used for early identification of the hazards. What we do here, we'll identify the hazards very early before resulting into accidents. Like against the raw materials, intermediates, final products, plant and equipment, interface among the systems, operating environment, operations, and also other facilities and also safety equipments. Other one is failure mode effect analysis. This is also one of the way of the assessing the failure rates of the equipment. This procedure considers each component of the plant in turn and also all possible failure modes and the rates and their consequences. Here what will happen? Here we will not consider the human errors. Here we'll see only the component failures or the equipment failures. The results are recorded in the standard format. HAZOP study is the well-developed form of FMEA. So this HAZOP came from FMEA technique. By the polishing all this FMEA, the HAZOP format came in out the process, which came in. Next. In this process, what will happen? The hazard identification were all known failure modes of the components or the features of the system are considered in turn and also undesired outcomes are noted. So if you see here, they're talking about the failure modes of components or the features of the system. Features of the system in the sense, the properties of the system, the nature of the system, or the working mechanism of the system. Those failures we will see here. And it is in a tabulation of the system plant equipment failure models. Each failure mode assigns a critical ranking. Human error or operational error is not generally examined in FMEA. Each failure mode assigned to a critical ranking. As I mentioned, criminal, human errors or operational errors is not generally examined. And this is the method derived from the reliability engineering. A product or a piece of complex equipment is divided into the components. And each component is studied to know how it can fail. So here, for example, if you take any big machinery, they will divide into multiple components or multiple machines or different parts. Then they will try to see each part component, how it can fail, at what rate, and also what could be effect on it or the other components. The failure rates of each item are determined and also listed. This method is used to determine the satisfactory operation life of the equipment, how the failure might occur modes, and also the frequency of the failure, and also the necessity for proper and also timely maintenance and replacements. And this knowledge can be used to improve the life and the quality of the product. And this is the preliminary more useful to the manufacturer than its users. So to whom it is helpful? It is more helpful to the manufacturers than the users. So for example, if you went for buying a car, they will say that 1 lakh kilometers, they'll have a guarantee or warranty, whatever it is. So because how they are confidently telling, up to 1 lakh kilometers, they would have tested, they have not found any problem till the 1 lakh kilometers. After the 1 lakh kilometers, there may be the problems which may come up. So that's why they're telling up to 1 lakh kilometer, there is a guarantee for their cars. The FMEA has its own limitations. Data of failure rates and also the calculation of failure frequency must be correct. And the method cannot analyze the problems created by a bad design or adverse equipment and also operation errors. For everything, there is a limitation. For FMEA also, there is a limitation. So this FMEA owns any data failure rates and also the calculation for the failure frequency must be correct. Otherwise, it will give a wrong result. So if you see as an example, a probable one failure before 1,000 hours of operation, if you take in any machine or equipment, reasonably probable one failure during 10,001 to 1 lakh hours, and very remote, which is very rarely happens, 1 lakh to 10 million, which is 10 lakhs hours of operation, and extremely remote after 10 million hours of operation. After 10 millions of 10 million hour, once you operated, then there is a chance of failure. That is the frequency of failure. So the failure frequency data is difficult to obtain. It is obtained from two types of testing of the component, that is performance test or reliability test. The failure classification distinguishes between possible effects of the assumed failure, and also four parts of classification is safe, marginal, critical, and also catastrophic, indicating increasing the severity. So once they have done this, they will categorize the failure into it is failing safe, or it is a marginal, it is critical once it happens, or sometimes it is a catastrophic. Okay, that is about FMEA. Then hazard operability study. Hazard is in a multidisciplinary team research deviations from the design intent through a fixed sets of guidelines or checklist or knowledge. So the first line itself you have to remember, it is a multidisciplinary team searches a deviation from design intent. What they search? They have a design. Then what they do? They look for deviation from the design intent. What is the deviated from the design? That they look into. Okay. This hazard can be conducted to check the design and also operating procedures for a new project or any existing one. It can also be conducted to improve safety of existing facilities. It is also useful before implementing significant modifications or for other operational or legal reasons. After carrying out the preliminary hazard analysis, PHA has explained earlier the plant component, systems, or missions. Okay. So if you see here in hazard study, what we do is the equipment part which can cause major hazard becomes known to us. So once you have done this, the equipment parts where it is contributing to the major incidents, we will come across. Now to find out our deviations or malfunctions leading to such event and its mode of operation. Once you know the effects, now we have to look for how it can go wrong. What are the reasons or what are the causes? It will deviate the design intent. For example, when I'm doing a reaction, my reaction temperature, it should not exceed 50 degrees centigrade, but it is going beyond 80, 90, sometimes 100. So how it can go wrong? So how it can go up to 100? Either my, instead of giving steam, I would have applied hot oil or hot water to my the chamber or the what do you call it? Jacket. Or sometimes what will happen? My cooling system got failure. Or instead of my operator, he is not starting the cycle properly. Once the reaction is completed, before it is taking the exothermic reaction, he has to stop the supplying of the steam or utility. He is not doing that. Then it is going for exothermic reaction, resulting in the temperature is going up. So like how we have to assess for what can go wrong. Then hazard studies carried out to determine the deviations from the normal operation and also the operational malfunctions, which could lead to uncontrolled events. So what will happen? Here we can identify the the deviations which can lead to uncontrolled events. Although the hazard study was developed to implement the experience-based practices, when a new design or technology is involved, its use has expanded to almost all the phases of the plant life, and it is based on the principle that several experts with the different backgrounds can interact and also identify more problems when working together than the working separately and also contributing their results. So it can be taken in all the phases in the design phase, or we can take up this hazard study on the working running plant, or you're doing maybe after a long time the plant has been under shutdown, again you are reopening it, or you're doing any expansion of the project or any plant. In this all the cases we can take up this hazard study. Therefore, hazard study is performed by a multidisciplinary expert, a group always including a work familiar with the installations. So here what will happen? We'll do a multidisciplinary people. Here all department people get involved, like maintenance, instrumentation, process safety, production people, safety, projects. Everybody will involve and they'll do a brainstorming session. What can lead to deviation of the design intent. And the examination procedure takes a full description of the process and systematically question every part of this, discover how deviations from the intention and also design can occur, and also decides whether these deviations can give rise to hazard or not. So based on that, they will split up, they'll take a what do you call process flow chart, then they divide each step, then they can question by brainstorming what can go wrong in this process. Then they will identify the root cause and they will take the proper control measures. So each of this design is analyzed with the questions formulated around the number of guide words. So which ensure the question pass to the test integrity, and also each part of the design will explore every convincible and way in which the design could deviate from the design intention, and then each deviation is considered for what are the consequences it can go to. So how it can be, if you see the stages of the hazard can be carried out in many ways. At the early stage of the development of the project, at the design freeze stage, once you have done your design, you are about to freeze your design. In that stage also you can do it. At the pre-startup stage also you can do it. And studies on existing plants, as I mentioned, in the working plant also you can do it. Studies prior to the plant modifications, before doing modifications also you can do it. And studies prior to the taking a plant out of the services. Then studies on research facilities. All these areas you can do the hazard study implementation. If you see the procedure for this hazard study will be carries out, define the objective and the scope. So why we are doing, how we are doing, what is the necessity and also scope, whether you are doing for only one process line or you are doing for the complete your manufacturing process. Then to select the team. So once you have defined the scope, you select the team. Then prepare for the study, then carry out the examination, follow, and also record the results. So they'll prepare for the study. How they prepare for the study? So they will look for, they'll get all the drawings and they'll get all the process parameters. Then they will do the examination based on the data which they have received. Then they'll take the follow-up actions based on the deviations identified and also the actions which they have addressed against the deviation. And the objective may be to check a design and to decide whether and where to build, and to decide whether to buy an equipment or to obtain a list of questions to put to the supplier, and also to check the running instructions and also to improve the safety of the existing facilities. These are the few examples of the objectives we can take. And the team may be a composed of a mechanical engineer and also the chemical engineer. Then R&D chemist will be there, production manager, project manager, instrumentation manager, etc. And the team should not too large. The team is headed by an experienced specialist from a work management or by a specially trained consultant. So it should not be a very big team, or it should be led by one technical specialist. After examining one part of the design and the recording of potential hazards, if any, the study proceeds to examine the next part of the design, and also it is repeated until the whole plant has been studied. So we'll start with the one part of the plant, then slowly it has to extend to the complete part of the plant. Yes, the guide words. We have seen 2 times in between the previous slides. What are the guide words? These are the 7 guide words, which are the very key important. Even in the examination also, they may ask what is mean by hazard and write down the guide words with an example of each guide word. So please remember, not or no. It is about the complete negation of these intentions. For example, the flow should go, or the flow has to happen. Here they're talking about no flow or not flowing, no flow at all. But my design intention is the flow should happen. No part of the intention is achieved, but nothing else happens. Then more, quantitative increase or decrease, more or less. What will happen? My intention is it is only 3 liters of chemical should go at one go, or 3 liters of chemical should pass through my meter at a one go. But here, sometimes it is going 4 liters, sometimes it is going only 1 liter. That is these refers to the quantities plus properties such as flow rates and temperatures, and also as well as activities like heat and also react. Sometimes more temperature or less temperature, that can be also considered, as well as a part of, as well as means a qualitative increase. All the design and operating intentions are achieved together with some additional activity. Apart from this chemical, there are other chemical also is getting added. And also it is a qualitative decrease. Only some of the intentions are achieved, some are not. So out of 5 chemicals, I could get only 3 chemicals into my reactor. And reverse, the logical opposite of the intention. This is mostly applicable to the activities, for example, reverse flow or chemical reaction. It can also be applied to the substances, example, a poison instead of antidote. So for example, instead of antidote, I've taken the poison. It is in a reverse action. Then other than, complete substitution. Other than means I have 3 chemicals, chemical A, chemical B, and chemical C. As per my intention, the chemical B has to come first, but the chemical A is coming first into the reactor. Instead of this, something else is coming. Or apart from ABC chemical, the D chemical which is coming, it is nowhere part of my reaction process. Okay. This is the step-by-step process of doing hazard. For example, here we are selecting a vessel. I'll just increase the font so that you can see it properly. Select the vessel. Like I can say vessel in the sense reactor or ANFD or any what do you call centrifuge, whatever the vessel, and explain the general intention of the vessel and also its lines. Then we'll select the line like any specific pipeline and explain the intention of the line. So we will explain why this line is for and apply the first guide word. So here we'll start with the for each line, we will apply all the guide words, not, more, less, part of, as well as, other than. All these guide words are applied to the each line and develop meaningful deviations, how we can happens and examine the possible causes. Then we'll identify the consequences of that. Then we'll detect the hazards. Then we'll make suitable records. Then we'll repeat 6 to 10 for all meaningful deviations, deviate from the guide words. Okay. Then repeat the 5 to 11 for all the guide words. Then mark line as having been examined. Then repeat 3 to 13 for each line. Then select any auxiliary or heating systems and explain the intention of auxiliary lines. Then repeat 5 to 12 for the auxiliary line. Then mark the auxiliary shown as being examined. So if you take a process, so based on the completion of your applying the guide words, then you have to keep it marked. It is complete. Otherwise, you'll be keep on doing the same. Then once you have done all this, mark the vessel as completed and repeat 1 to 22 for all the vessels on your flow sheet. It is nothing but your process sheet. Now we'll see ETA. It is event tree analysis. This is also one of the technique we use for the investigation of the accidents. The event tree analysis is the method to illustrate the intermediate and the final outcomes which may rise after the occurrence of a selected initial event. Selected initial event means the root cause of the incident, how it can leads to major accident. For example, leakage of any gas or the generation of a spark. These are the initial events. How this spark can lead to catastrophic accidents or the major accidents. This technique is complementary to fault tree, but in a reverse direction. So there are two techniques. One is event tree and fault tree. So whereas the fault tree starts from the final event and also works from the top-down approach. And the event tree begins with the initial event, such as power failure, and explores all the possible outcomes of working on the bottom up. An illustration we can see now. These are the reverse cases. If you see this event tree, so here the release of flammable gas, it is an initial event. So what will happen if the release of any flammable gas, either it result in a jet flame, if it ignites immediately, if no, it disappeared into a cloud form. Then formation of combustible mixture, say yes or no. If it is ignition source, if there is an ignition source present, it result in combustion of vapor cloud. If no ignition source, what will happen? It will disperse safely. Then if you see a resulting in this combustion of vapor cloud explosion, blast effect. If the blast effect, what will happen? It should be result in unconfined vapor cloud explosion. If no, there will be a flash fire. This is how the event tree will do. It is from the initial event to the final events. And then initial event to the final result of the event. What can go wrong? So these are some of the examples of ETA. You can do it. Failure of a pump. So what can happen? Then a failure of steering off, and also failure of water cooling, and stoppage of moderate and also mistake of. So you can initiate these things. Once you got this PPT, you can try to brainstorm yourself by applying this samples so that you can understand better. Then fault tree analysis. It is exactly opposite to the reverse. There we have seen initial event as a leakage of gas. In the fault tree analysis, what will happen? We'll start from the top. Unconfined vapor cloud explosion. Then we'll dig down. Okay, how unconfined vapor cloud explosion has happened? Either there is a presence of a spark or there is a presence of vapor cloud formation. Why vapor cloud formation has happened? Because of leakage. How leakage has happened? Because of a spillage or motor failure or any pipe failure, etc. So that is how we'll do a reverse method from fault tree. So if you see a fault tree, or you can remember as a fault tree means చెట్టు నుంచి పైనుంచి పడటం, from the falling down. It is a method to represent the logical combination of various systems which leads to a particular outcome, which is a top event. It is in a graphic model of determination, various combinations of equipment, faults, and also failures that can result into accidents. You can see here as an example, we can understand better. If you see, it is in a top event, probability of fire. So the ignition source must be present after mixture is flammable. So what can go wrong? Either presence of a fuel, oxidizer present, mixture is flammable, ignition source. If all these things are there, then it will leads to this a final event. Then ignition source. What can be the ignition source? The lightened match or other open flames or electric arc or spark or hot surface, and then others. These are the possible ignition sources. Okay, this is how it will happen. Event tree will be from initial event to the top event. Fault tree will be from top event to the digging out of initial events. Fault tree will be like a accident investigation. Once the accident happened, we'll investigate or we will find out for the root cause of the accident. In event tree will be, we will take the unsafe condition. So how this unsafe condition will leads to accident? We will see the final events. And these are the some of the examples for the fault tree analysis: injury to, damage to, or explosion of, loss control of, or rupture of, loss prevention, etc., etc. Okay. With this, we have done this topic. If you have any questions, we can discuss. We have less than a minute. Today, we have discussed about hazard identification techniques, risk analysis, risk assessment, risk management, hazard operability study. Then we have seen fault tree analysis. We have seen event tree analysis, and also we have seen PHE, preliminary hazard analysis.